Slide saya udah bisa dilihat, Pak Edi?
Sudah kelihatan.
Baik, sekali lagi terima kasih, Pak Edi. Selamat sore, Bapak-bapak dan Ibu-ibu, Ibu-ibu dan rekan-rekan serta online webinar yang saya hormati. Assalamualaikum warahmatullahi wabarakatuh. Sebelum saya menyampaikan materi webinar yang pada kesempatan kali ini terkait digital twin pada proses automation menggunakan SIMIT sebagai simulation platform, mohon izin ya pertama-tama untuk saya memperkenalkan diri. Jadi nama saya Ibnu Holdun. Role saya di PT SIMIT Indonesia ini adalah sebagai portfolio consulting untuk bisnis unit process automation. Ya, timnya Pak Danu kebetulan Pak Edi. Dan kebetulan juga pada kesempatan kali ini, seperti yang tadi disampaikan, saya ditemani oleh rekan saya, Denny T. dari SIMIT Singapura. Berbicara digital twin, sebagaimana kita ketahui bersama, teknologi ini merupakan bagian dari transformasi digital ya yang saat ini sudah mulai banyak diaplikasikan di berbagai sektor industri. Sebenarnya secara definisi sendiri adalah suatu virtual representatif ya dari current atau future physical reality atau suatu objek, di mana objek ini bisa dalam skala kecil, misalnya suatu equipment ya, baik itu motor, valve, sensor, dan berbagai macam aktuator lain, sampai dengan objek dalam skala yang lebih besar ya, misalnya suatu produk, proses ya, bahkan plan, di mana nantinya kita bisa memonitor health status dan behavior dari objek-objek tersebut. Kira-kira seperti itu pengertian awalnya. Nah, berikut ini adalah konseptual dari digital twin pada proses automation. Di sini ya bisa kita lihat digital twin itu di-create dengan mengkombinasikan ya atau mengintegrasikan berbagai macam teknologi dan solution yang ada di proses automation. Mulai dari engineering, kita ada yang namanya COMOS. Jadi COMOS ini merupakan global data center, Pak, di mana kita bisa mencentralize semua dokumen-dokumen atau plan information ya, mulai dari engineering, construction, automation, electrical, civil, mechanical, dan lain sebagainya. Ya, contohnya misalnya CLD atau control logic diagram, atau sistem engineering naratif, SOP, bill of material misalnya. Kemudian untuk dokumen-dokumen elektrikal seperti misalnya single line diagram, schematic diagram gitu ya, PNID dan lain sebagainya itu di dalam Global Data Center COMOS ini. Kemudian untuk operation dan maintenance kita bisa menggunakan teknologi dari SIMATIC PCS7 atau SIMATIC PCS Neo ya sebagai backbone untuk meng-create yang namanya digital twin tadi. Dan yang terakhir simulation. Ya, di sini baik static maupun dynamic simulation kita bisa menggunakan SIMIT sebagai simulation platform di mana kita bisa meng-create tools yang nantinya bisa kita gunakan sebagai wadah ya untuk melakukan commissioning atau FAT atau SAT secara virtual. Lalu kemudian kita juga bisa membuat suatu environment ya untuk operator training station dan juga melakukan yang namanya realistic process simulation. Kira-kira seperti itu. Nah, ini adalah mapping antara physical reality dan juga virtual world atau dunia digital. Nah, di sebelah kiri kita lihat bahwasanya ini adalah piramid dari control system pada proses industri. Di paling bawah tentu kita berbicara plant atau mesin ya untuk mendukung jalannya proses tersebut. Kemudian mesin itu didukung atau disupport sama aktuator atau sensor sampai dengan semua informasi atau semua peralatan itu diproses ya dan di-execution baik secara fully automatic atau semi automatic oleh controller. Sehingga kita human bisa memonitor ya sekaligus mensupervise jalannya proses melalui HMI. Di sebelah kanan virtual world di sini adalah bentuk digital dari physical reality yang ada di sebelah kiri. Nah, di sini saya lihat pointer. Nah, ini adalah SIMIT ya, simulation platform di mana SIMIT ini kita gunakan untuk mereplika dan juga mensimulasikan semua objek yang ada di physical reality secara virtual. Nah, simulasi yang bisa kita lakukan dengan menggunakan SIMIT itu mulai dari uh, simulation signal ya, atau signal test ya. Lalu kemudian kita juga bisa melakukan yang namanya simulation equipment, baik itu drive atau misalnya transmitter, sensor dan lain sebagainya, sampai dengan kita melakukan simulation terkait proses itu sendiri. Dan SIMIT ini bisa juga diintegrasikan dengan berbagai macam simulator lain seperti GPROMS di kita ada untuk desain, dan juga untuk 3D-nya ada yang namanya MX MCD seperti itu. Nah, secara topologi atau desain, SIMIT ini bisa kita develop ya dengan dua cara. Yang pertama adalah software in loop. Artinya dengan menggunakan SIMIT kita bisa mereplikasi ya semua physical reality dari mulai controller, I/O, kemudian aktuator, client machine dan lain sebagainya itu fully menggunakan software SIMIT. Atau kita mengintegrasikan SIMIT software ini dengan real controller sehingga nantinya data yang akan diterima oleh SIMIT ini based on actual condition yang ada di pelan. Seperti itu kurang lebih. Nah, ini adalah perspektif ya dari project planning atau engineering proses. Kemarin-kemarin ya, umumnya automation itu selalu berada di fase paling akhir dari sebuah project ya. Fokus pertama kita tentu berbicara dari produk yang akan kita hasilkan. Kemudian bagaimana proses untuk mendukung produk tersebut, diikuti peralatan baik itu mechanical atau electrical untuk mendukung jalannya proses. Setelah itu baru kita berbicara automation ya, bagaimana membuat proses ini bisa sustain baik itu semi otomatis ataupun fully otomatis gitu, sehingga produk ya yang kita hasilkan itu bisa konsisten secara quality. Nah, saat ini sebenarnya hampir mirip dengan apa yang dilakukan kemarin-kemarin. Hanya saja kita membuat duration atau waktu dari setiap proses ini jauh lebih efisien. Nah, kedepannya dengan adanya SIMIT Simulation Platform berbasis digital twin ini, kita bisa melakukan engineering proses ini secara paralel. Artinya pada saat kita mengkonsep suatu produk, kita juga bisa langsung membuat proses untuk produk tersebut dan juga melakukan spesifikasi dari material yang nantinya akan kita implementasikan di real production. Termasuk juga sebelum itu diimplementasikan, kita bisa membuat yang namanya virtual commissioning. Jadi untuk mengetahui apakah nanti prosesnya memang berjalan sesuai dengan apa yang kita inginkan. Dan juga membuat yang tadi saya sempat bilang environment untuk operator training station. Nah, oleh karena itu simulation ini menjadi basis ya atau dasar untuk collaboration di masa yang akan datang. Ini adalah gambaran kira-kira added value ya dari SIMIT berbasis digital twin ya dalam aspek khususnya operation dan engineering ya. Yang pertama, data baik itu yang ada di operation maupun yang ada di engineering itu bisa diintegrasikan secara seamless. Kemudian kita menghindari yang namanya downtime ataupun error, karena sebelum kita implementasikan sistem yang sudah kita buat, kita bisa melakukan yang namanya testing atau simulation seperti itu. Dan di sini kita juga bisa menambah confident nantinya untuk operator sebelum mereka berintervensi secara langsung proses yang ada di lapangan. Jadi sebelumnya mereka bisa melakukan yang namanya simulation, trial and error di environment yang sudah kita buat ya, seperti itu. Dan ini semua sebenarnya kaitannya bagaimana nantinya kita mereduce yang namanya operational cost ya, memastikan bahwasannya plan kita tuh safe, lalu kemudian reliable, dan juga ya meningkatkan yang namanya safety. Di samping itu, benefit lain dari teknologi ini adalah kita juga bisa yang membuat yang namanya failure scenario. Jadi pada saat startup, operation, maupun pada saat plant shutdown, itu bisa berjalan dengan smooth. Ini kira-kira referensi ya, salah satu referensi yang kebetulan di luar country kita, Indonesia. Jadi di sini plant tersebut menggunakan SIMIT untuk membuat yang namanya shadow plan. Dan juga dia meng-create yang namanya operator training station atau OTS. Nah, shadow plan ini value-nya atau added value-nya adalah dengan adanya shadow plan, mereka bisa memigrasi sistem yang lama ke sistem yang baru, ataupun mengupgrade sistem yang lama ke sistem yang baru tanpa dalam keadaan plan tersebut online atau dalam keadaan plan tersebut running. Jadi khususnya nanti plan-plan yang memang tidak memiliki regular shutdown yang cukup memadai, sebenarnya ini sangat membantu sehingga commissioning, FAT itu bisa kita lakukan secara virtual. Kemudian dengan adanya OTS, operator bisa beradaptasi dengan fitur-fitur atau sistem-sistem yang nantinya ada di versi terbaru dari sistem tersebut. Kira-kira seperti itu. Kemudian referensi lain dari sektor energi, di sini SIMIT digunakan ya untuk men-short commissioning time ya. Jadi dengan adanya virtual commissioning atau commissioning yang dilakukan secara virtual, urutannya kan biasanya pada saat kita melakukan execution project ya, itu adalah kita mengkonfigurasi ya, melakukan engineering dari sistem yang akan kita persiapkan, kemudian FAT ya, baru item tersebut diinstalasi di plant, dan kita lakukan yang namanya site assessment test ya, atau commissioning gitu, untuk memastikan sistem ini memang akan berjalan dengan baik. Nah, dengan adanya virtual commissioning ini, kita bisa membawa fase paling akhir commissioning time itu ke fase paling awal gitu. Jadi di sini tidak hanya signal test yang bisa kita lakukan, bahkan sampai dengan proses, dan itu nantinya sangat membantu untuk men-shortening waktu dari commissioning. Dan juga yang tadi tempat saya sampaikan terkait value skenario. Kira-kira seperti itu ya pembukaan dari saya. Terima kasih banyak atas perhatiannya. Untuk materi selanjutnya akan disampaikan oleh rekan saya, Denny. Denny, time is yours.
Oke, terima kasih. Thank you. Ya, I share webinar screen. Okay, can see? Good.
Yes, we
Yep.
can see.
Yes. Thanks for all the time. Yeah, I think last year I visited you guys in your,
Yeah.
Yeah. So far it has been 1 year. Yep. Today we talk about SIMIT. Yeah, as mentioned by Ibnu. Yeah, SIMIT. Basically we can use it for simulations, operator training, OTS. Basically we can create digital twin with SIMIT. Okay. This is a typical questions from the plant owner and also the operator. Yeah, how to increase efficiency, reduce the time during commissioning, reduce risk. Yeah, risiko. Yeah, how to train the operator efficiently. Then how to raise the quality, cutting costs. Then yeah, migration during the life cycle. How do you reduce the risk? Yeah, basically we can use SIMIT. Yeah, this is also the same slide shown by Ibnu. So before we use it, we implement in the real plant. Yeah, we test it with SIMIT. Yeah, let's say with SIMIT, we can use a virtual controller. We can also use a real controller. Yeah, SIMIT can be used in all the industry, chemical, energy, oil and gas, water, wastewater, pharma. Basically, all the industry can use SIMIT as long as there is a controller. Yeah, a PLC is in place. Yeah, so basically this is comparison between a real plant, yeah, at different level of simulations, starting from your operator stations, controllers, IOs, instruments, motor, to your plant and machines. Then in a virtual world, yeah, as you can see that the orange part, yeah, is done by SIMIT, simulate signal, device, and also the process of machines. Yeah, this is basically the use case of SIMIT. Yeah, when people think of simulations, they would thought that it's very difficult, very comprehensive, not easy to start with. Basically, it really depends on the detail that you want to achieve. Yeah, if you want to doing some testing for automation software, yeah, you just simulate the I/O. Okay, this is the look and feel in SIMIT. yeah, the interface. You can just toggle the I/O. You see the result. Basically, this one help, yeah, the customer or the user, end user, to run the FAT, yeah, factory acceptance test. And this is the loop for the virtual controller, as if the controller or the PLC is running in your system. Next step, if you want to have a supported and FAT or loop check, yeah, we can create some logics. Yeah, this is the one. We do have a library. Uh, the library basically is the one to simulate your devices. Okay, in this example, we have a motor. Yeah, so through this faceplate, you can simulate some motor fault, tripping, motor current, fault. Yeah, within this working window or faceplate. Okay, yeah, this is example of real world. If you have a real valve, then we have some control. For example, in this case, PCS7, some logics controlling this valve. Whereas in the virtual world, we have these components to emulate or simulate this valve. Okay, it helps in the OTS and also the virtual commissioning. Yep. For SIMIT, we have many library free for download. Yeah, basically just go to our support website. Yeah, you can download the libraries available, be it for drive, instruments, RFID, yeah, some control library. Okay, then if you want to use it for lean OTS, for example, yeah, lean OTS or operator training system, or a simple automation training or simple process. Okay, you can use the FlowNet chemical basic library for the flow simulations. Yeah, this is especially useful in process industry for the PNID simulations. Or you can use the blocks or components available to design your process logics. Yep, this is an example of how what can you use with a lean OTS. Yeah, these are the components in SIMIT. Then this is your process graphics or interface. Okay, for the operator, they just sit in front of this interface doing some process control or plant control, whereas the SIMIT can do some scenario, yeah, to test the operator. Okay. Yeah, then if you want to have a multi-component simulations, for example, if you have a very the medium is a certain chemical with certain compositions, yeah, then we have this OTS, which is multi-component simulations. It comes as a solutions. Yeah, it is not just a typical a simple water, steam, or just normal liquid. Yeah, then we have this so-called more comprehensive OTS solutions. Yep, we also have this pipeline library available. Yeah, this is example that how you can achieve with the HMI SCADA. Then you have the simulation for the OTS. On top of the built-in FlowNet or Chem basic library, yeah, you can build your own library. Depends on your use cases. Okay, and then these are the product and the solutions come with SIMIT. We have the standard library. We have this one come with a SIMIT installations. Then we have chemical basic library. Yeah, for chemical industry. Then we have instruments library. This one free for download. Then we have the device library for device level simulations. Conveyor tech library. This is for conveyor belt transportation library. We have use case for Colombia MRT. Basically, they are using this. Then FlowNet library. Yeah, similar to chemical basic library, except that you can build your own edit components. Then for solution wise, yeah, if you have a dedicated medium or ingredient for simulations, yeah, we have the solutions to build the components for you. Then we also have this water and pipeline library. Basically, it extend the FlowNet library, but include the typical use cases in water. Okay, we also have power plant library. As we may know that Siemens do have a gas turbine delivery. Yeah, basically it has been tested with this power plant library, yeah, for the virtual commissioning. Yep, we also have this electrical network library. Yeah, basically you can get many components like generators, turbine. Later we can take a look what are the components available. Okay, one of the reference, additional reference, basically this is a PCS7 with SIMIT in Aksonia in Saudi Arabia. Yeah, for the reverse osmosis. Basically, you use SIMIT for testing the applications and also for the operator training. Okay, let me show you some application example, what you can achieve with SIMIT. Yeah, basically SIMIT is just like it is a very powerful tools. I would say that it's just like Microsoft Word, yeah. Depends on your skill, depends on your knowledge, yeah. Familiarity with SIMIT. Basically, we can come up with magic, yeah. Okay, we have customer who is in cement plant. So they have defined what will be the workflow. Then they start to design the components available. Okay. Subsequently, this component can be reused in all the cement plant. They can sell it. They can package it as a library. Yeah, then they can call it as a cement library. Yeah, separator. Okay, all these are built by the customer or the SI or partners themselves based on the requirement. Okay. Yeah, oil tank, oil pump, and pipe system, filter, pneumatic conveyor. Yeah, for power control applications, yeah, Siemens or PC7, we do have these power control packages. At the same time, for the SIMIT, we have the components or libraries tally or coordinate or matching the power control applications. Yeah, this is under electrical network library. Let me share with you some of the components you may be interested. Yeah, so as you can see that we have different components. You can see that you have two circle, yeah. So you just drag and drop the components, then you just link the circle together to create the single line diagrams that you want. Okay, these are some of the components available. Yeah, motor load, switches. This is basically the working window. So if you double click this component, you will get this working window. After you turn on the simulations, all the calculation will be done by the simulator. Yep, this is also some of the components available in the electrical network library. And then we do have distillations. Yeah, some example for process. Yeah, it look complicated. Basically, you start small. To start, you build a simple simulations. Subsequently, you add more and more component, fine tune your simulations. Yeah, subsequently you get a very comprehensive model. Okay, yeah, this is a simple one, a chemical basic stirrer tank. This is the correspond PCS7 view. Okay, some example of flow net reactors, raw materials. Yeah, basically you just drag drop. No intensive programming required. Yeah, just use the blocks and tie it together. Okay, then the question will be what will be the timeline of implementation? What will be the recommendation? Okay, the several group which is beneficial of using a SIMIT for project managers. Basically, they do not need to have extensive modifications. You can have an exact image of the real plant. The customer satisfaction increase because they have tested, yeah, before seeing the real, having the confidence of their plant. Yeah. Then for the engineer wise, they can test it, okay, to debug, yeah, before they go to the site. Then the project will be finished in time. The operator are prepared. Then for the operator and service technicians, you can optimize their personal training. Yep. Subsequently, with the model they have, they can do the continuous training. Okay, increase safety. Yeah, basically they're more confidence, less chance to make error. Okay, for the use case of virtual commissioning or FAT, goal basically to prove the functionality face to face to the customer, lighten the acceptance by the customer, so the customer will be feel confidence. Yeah, so during FAT, yeah, they can test it. Yeah, basically 95%, for example, yeah, 95% of automation simulations, and then a very simple process simulations. Okay, so the customer can test out the control strategy, the sequences, the shutdown sequences, SOP. Okay, then any trippings required. Then for additionally, once you have the model, you can use it basically for operator training to train the operator before the start of production. Yeah, here. Then you can discover what will be the best behavior or optimizations. Then you can give exam to the plant operators. Yeah. So you can do it before the commissioning and also after commissioning. Yeah, when the plant is running, you can use it. Yeah. So this is example. You will always start small. Yeah, with the low hanging fruit. Start with the most critical one. Okay. Subsequently, the model become more and more so-called perfect. Yeah. Okay. Then you can reuse it. The model. Yeah. You can see that during the FAT, the model is complete. The model plus virtual controllers can be used for virtual commissioning. Then during production, you can use it for OTS or digital twin. Okay, so basically for SIMIT, yeah, it is there are beneficial benefits of it, time saving, reduced risk, and subsequently cost saving. Okay, this is what you can achieve with SIMIT. Then for SIMIT, I have something to show you that. Yep, our latest version will be 11.1. Some may think of, okay, SIMIT, is it only the use case for process plant? Basically, it is no. There are some core simulation solutions with SIMIT. Okay, for example, machine simulations. If you have a PLC Sim Advanced, or you have a 1500 S7 1500, basically we have a simulations called machine simulator. Yeah, as mentioned by Ibnu, yep, our SIMIT can have a NX MCD connector to the kinematic models. This is another software suite by SIMIT. Basically, is simulating the kinetics of the machines or devices. Yeah, it is coupled with SIMIT. Then SIMIT will be coupled to PLC Sim Advanced for the control the logics. And inside our machine simulator, yeah, it has libraries to simulate those drives, yeah, digital drives, yeah, all these are available. Okay, so it is very straightforward. The left side, this one is SIMIT, then this one is NX MCD. Yeah, we can just select the NX MCD projects, then we can just run it. Very intuitive. Okay, then some of the customer may require high fidelity, yeah, domain specific process simulator. Siemens, we do have a company or solutions called GPROM. Okay, basically they are providing the high fidelity process simulations. Okay, then as you can see from this side, same, the OS will be the same. Then we can use a real controller or a virtual controller. For the field level, we can use SIMIT. If you want to have the real plant, which is high fidelity, we can also have a GPROM. Okay, we can couple it with GPROM. Yeah, so this is the example of core simulation with GPROM, very dedicated chemical reactions. On the left side is PCS7. Some of the devices are simulated with SIMIT. Then the main process, yeah, which is calculation intensive, it can be simulated by GPROM. Okay, so as long as you have a semantic controllers, 1200, 1500, or PCS7, you can simulate with SIMIT. Okay, SIMIT is a very interesting software. It is a continuous innovate software. As you can see the timeline, the release, the version release is very fast. For example, in version 9.1, release chemical basic library. Within 2 years in version 10, more and more functionalities come up. Machine simulator, then 10.1, GPROM coupling, OPC UA, then NXMCD in 2020. Yep, 2021, table reader, FMU 64-bit. Yeah, it is also possible to have the connectivity with MATLAB. Okay, we also have application note about it for SIMIT with MATLAB. Then for the latest one, version 11, yep, with TI portals, PLCC advanced, yeah, 2022. As you can see that the innovation is like yearly, yeah. It is very fast-paced and very comprehensive and useful. Okay, then let me go into a demo. Before that, any questions from the audience? Am I too fast?
No, the question is after presentation completed.
Okay, sure. Yeah. Okay. Then this is example of SIMIT. You can, I think you can have the Ibnu will provide you the package. Yeah. So once you have the SIMIT, you just launch SIMIT SP. Then in SIMIT SP, okay, on the left side, let me stop it. Let me stop the simulations. Yep. Can see my screen. Just make sure. Okay. So on the left side, basically, when everything is blue, basically this is in engineering mode. We can add new coupling. Coupling basically is the connectivity from SIMIT to external party. So if I double click new coupling, you can see that we have so many options available. PLC Sim, PLC Sim Advanced, and virtual controller. This is for Simatic controller, Siemens controller, Siemens PLC emulations. Then you can see that we have OPC or standard OPC connectivity. SIMIT can act as OPC DA client, DA server, UA client, UA server. Yeah, also some shared memory functionality. Then GPROM, connect to GPROM, connect to NXMCD, connect to plant simulations for shared memory, and then for table reader. Okay, yeah. So you can create some simulations within SIMIT. Then if you have a third-party simulator which has only OPC, basically you can pulling the data from the external simulator through the OPC connectivity. Okay, and this one there. So in this case, I do have a virtual controller. Yeah, this is one of the controller from PCS 7. Then for the device simulations, yeah, basically we can make use of the components on the right side. Yeah, as you can see that, well, we have many components. Yeah, first one is chemical basic library. So that all these components are related to chemical basic library. Yeah, pump, turbine. Okay, then we have a standard library. Yeah, standard library, just normal blocks. Yeah. Then we have FlowNet library. Then we also have some templates. For individual device simulations, basically we can just drag and drop a template. We connect the I/O. Let me zoom in a bit. Yep. For this green and red color, basically is connectivity to the external coupling. As you can see that this one is AS01, basically is connected to AS01. This one AS01 also is connected to AS01, except that this is an input into SIMIT and output from SIMIT. Yeah, so basically it's an output from the controller, input to SIMIT. Okay, this is for device simulation. Once you have done with the device simulations, if you want to move one step for above, yeah, okay, we can have a process simulations. Yeah, this is the example of process simulations. These are basically all the components available. Yeah, let me click. So this is example of PT nodes where you can define the pressure and temperature. Then this is a network parameter, for example. With this, you can define some parameter with regards to the network. What will be the density, thermal gas factors, gas constants. Yeah. Then the next one, this will be the measurement. This is a valve. Yeah, you can fine tune the valve. Then, for example, we have a tank, a reactor, the height, the volume. Then, yeah, all these parameter with regards to this reactor. Okay, similarly, we have pump. The plus point for SIMIT is you can just use the component, just put key in the data sheet, yeah, from the devices. Okay, then to run the simulation is very easy, straightforward. Just click run. Okay, then you can see that you call up a virtual controller. Yeah, virtual controller. It pop up at my other screen. Yeah, it pop up a virtual controller. So the logics is running inside this virtual controller. Yeah, when it is in orange, now we are into the simulation mode. Okay, if I highlight, yeah, I can see the running value. Yeah. So for example, if I open the valve, yeah, I can open the valve. Yeah, yeah, you can double click any component. Then you can expand the, you can see that the delta P, this is example of chemical basic, which is more relevant to process. You can see that the delta P across the valve, what's the mass flow across the valve. Yeah, similarly for the boundary conditions, yeah, we can simulate, for example, if you want to change the pressure, okay, you can see that the flow also changed, the delta P also changed. Of course, with this, you can simulate some abnormality like overpressure, leaking. Yeah, subsequently, you should see alarming to train the operator, see how they can behave, or whether the logics in the controller is doing the proper way. Okay, yeah, so basically, it's quite comprehensive. And all these calculation, you can see it in the coupling. So all this value will be fed into the controller subsequently to your graphic. Also, if you want this value to fit into your MATLAB or OPC UA, yeah, it is also possible. Just create a coupling and link the value accordingly. Okay, it may, if you want to create a simulation, it's quite straightforward. Just go to projects, double click, click a chart. Then, for example, you just drag and drop. For example, systems. I want to have a pressure PT node, PT node. Then I can put a pump in between. I can put a valve in between. Okay, I'll just make a simple one, yeah. Okay, then I can just connect. Okay, then for example, if I want to control the flow, I can use a slider, for example, yeah. As simple as that. Once it is done, I just click save, prepare changes. Okay, then activate changes. Okay, then if I open up, I just go to the orange, double click the chart. Yeah, this is the one that I have created a few minutes ago. I easily open up the So for example, this one I put the boundary condition at higher, 5 bar. If I open and start the pump, yeah, you can see that the calculations come into the picture. Yeah, 2.89 kg per second. Yeah, yeah, keep changing. Okay. Then if you want to fine tune, for example, if you want to fine tune the pump or valve size, yeah, easily you just go to the parameter, yeah, change the valve size, let's say to 50. Yeah, immediately you can see that the mass flow has changed tremendously. Okay, the plus point of SIMIT is even you do not have any process background, yeah, you can easily create some process simulations for your virtual commissioning and also the FAT with the customer. Okay, it will be a plus, yeah, if you have a process engineering background or chemical engineering background, yeah, to create such kind of simulations. And also, you can also do a snapshots within SIMIT. Yeah, snapshots. So at any point of time, you can revert to the snapshots, yeah, by giving the last date. So you can repeat your SOP, startup procedures, shutdown procedures, yeah, by double click the snapshots. Okay, and then with SIMIT, if you are very interested to create your own components, yeah, you just click, for example, yeah, just take any components, yeah, for example, min-max, okay, min-max. If I double click on component, it will call up something called a SIMIT CTE, yeah, component type editor. This will be very useful if you want to design your component, then subsequently you can create a library out of it. Yep, this is the so-called engine behind or the creation of the component. So I take a min-max as an example, yeah. So this particular component has been designed since 2016. Okay, no password protections. That's why you can edit this. Okay, as you can see that this one, the name of this component, minmax.simcmp. Yeah, so basically all the components, yeah, once you create it, yeah, you can bring with you. You can package it as a library. You can basically package it and sell it as an IP. Yeah. Okay, then you can password protect it. And this is where we design. Yeah. We can define the connectors, define the parameters, some initializations. Okay. Yeah, some calculations. Functions may or may not have. Then connectivity does not have. Then the operating window, the basic symbol and the operating window. This one don't have. Yeah. Let me find something more comprehensive. Maybe pump. Okay. So for example, I took a pump. Yeah, it comes from FlowNet library. Yeah, design since 2011. Yeah, yeah, connectors. Yeah, speed control, mass flow, all this. Parameter. The state basically is the memory, how the calculation takes place. Initialization of the pump. Yeah, the calculations. Topology basically is the connectivity. Yeah. Okay, the basic symbol of the pump, just like what we see, and operating window. Yeah. So with CTE, you can design your own library, just like what I said previously. Yeah. it is just like Microsoft Word. Yeah, you can create magic out of it. Yeah, depends on your requirement, depends on your knowledge, then depends what you want to achieve with SIMIT. It is very flexible as long as you can imagine it. Yeah, you can design out of SIMIT. Okay, it is the unlimited possibility tools, yeah, for you to create magic out of it. Okay, yep. So basically, this is example in process simulations. Yeah, SIMIT. And then let me stop the simulations. I want to show you some example, yeah, not limited to process. Okay, let me close it. Okay, we have sample projects. Let's retrieve it. Okay. Then this is examples that we can use with SIMIT. It is very flexible. Yeah, you can always start small. Example of use, for example, analog memory. So you write in, you store, yeah, basically it's store in your memory. Okay. Then conveyor belt, cam this. Basically the simulation is based on this. Then circuit breakers, equalizations, temperatures, light barrier. You can also create animation out of it. Yeah, compressed air. Yeah, really depends on your creativity, yeah, and your requirement. Yeah, the calculations. Pressure regulator. Redundant feed. Yeah, this is example for electrical, yeah. Diode with a voltage. Then relay circuit. Yeah, this one is a simple one. So you can see that we can create the connect, so-called the control here, but the calculation is important. You can also create your own. This is what we call a macro. Yeah. Okay. Then basically this is animation of this. Okay. Tank level, inflow, outflow. Then you calculate. Okay. This is a transfer carriage with the animations. Yeah. Yeah. Voltage switch over. Okay. You can easily use SIMIT to achieve this kind of simulations. Very straightforward and very easy. Yeah, by utilizing all the components available here. Yeah, very comprehensive and easy to use. Just drag and drop, connect. Yeah, yeah. So basically, this will be the demo and a presentation from my side. Yep. Any questions?
Okay, thank you very much, Pak Denny, for your nice presentation. Kita bacakan ya ini ya pertanyaan ini bermuncul. Ada 2 pertanyaan. Silakan yang lainnya ditulis saja di chat box ya. Pak Denny bisa bahasa Indonesia kok ini sebenarnya.
Yeah, let me check the chat box.
The first question coming from Pak Nasrul Effendi. Apakah software ini free? Ya, ini pertanyaannya. Silahkan, Pak.
Oh, free ya?
Iya, ini pertanyaannya.
Let me share with you. Let me share with you one slide. Yeah, the SIMIT installations. Yeah, SIMIT installations. You can get it. You can get it from our support website. Let me share the screen now. 1 minute. You still can see my screen. Yeah. Okay, can see my screen?
Yeah.
Okay, this is the one. So basically, SIMIT is very straightforward, very interesting. You just go to this Siemens support website, then you just key in this number, yeah. You can download the installation. Okay, once you download the installation, you will have three shortcut. One of them is called demo version. Yeah, you just double click the demo versions. Basically, you can do whatever I do just now. Yeah, if you look at my screen, even for my installations, I have three. This one with license, then this one is SIMIT demo. Yeah, once I install, I will get all these three. This one is license free. Yeah, you just double click and use it. So I encourage everyone to to download and have a try.
Oh.
Mm. Let me share the link also in the chat. Yeah. Mm. Okay. Yep. So basically, this is the website. Yeah. Any next questions?
Oke, ini ada Pak Audrey ya. Please, you can use the microphone or you can say in Indonesia.
Ya, silakan.
Okay, thank you, Mr. Eddie. I would like to ask for Mr. Danny. So you said that the simulations can simulate all the components, right? But then can the noise on the plants also included into the equation? I mean, into the simulation in SIMIT? Because we need to implement the controller or signal conditioning as for the noise happening in the plants. Can you explain?
Can okay. Can we simulate the noise which is happening in the plant?
Noise or maybe a denoising to processing the signal with noise.
For our there are some component within SIMIT. Yeah, basically it is a noise generator. But again, the noise generator, right, in SIMIT basically is a random value multiplied by the fit value. Yeah. So, but it can't it has a noise simulator, but it may not be the noise that happened in your real plant. Yeah. You can see from our there are some components. Yeah. Yep. This is one of them. The random. Yeah. Basically, it fit in something. It fit in a value. Then through a random values, yeah, it is multiplying by the PV. Yeah, this is an example of noise simulations in SIMIT. Yeah, but it may not represent the actual noise in your plant. Yeah.
Okay, I see.
Yeah.
May I ask another questions? But
Yeah,
it's
sure.
more technical.
Mm.
Yes. I see that the simulation design is using PNID, but then can we set the exact heights or length of the pipe connection?
Oh,
As for
can.
the okay.
Yes. Height is also height also possible. That's good. So let me show you. I just double click. Okay. So basically, we make use of the components available. And these components are very comprehensive. For example, I drag a pump. So the pump, it has a jaw height. Basically, it's a height, the location of this pump. Yeah, one of them jaw height. Then, for example, if you want to simulate the pipe length, so I just drag and drop a pipe. So you can see that one of the parameter, the length. Yeah, you can easily put it 2000 meter. Okay, the distance that you want. Then the diameter, the roughness, viscosity, number of elbow, number of bending. Yeah. So if you want to see what's going on, you can easily highlight this one. Okay. Then I click F1. Yeah. So you call up the documentations. Yeah, it is very comprehensive. Just make use of the components available. Yeah, if you can't find the components, basically we can build it. Yeah, most of the components in the chemical basic chemical plant, yeah, is covered in this chemical basic library. Yeah, this is example of the description of this pipes component. Yeah, what is the material of the pipe? What should be the number to fill in? Viscosity, pressure drop. Of course, there are so many components available. Yeah. 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 We provide many intensive calculation inside. Yeah, but for us, we just fill in the parameter. Of course, we need to know what is it all about. Yeah. It is quite comprehensive. Yeah. Okay.
All right. Thank you, Mr. Denny.
Thank you.
Okay. Next question is coming from Pak Dasri. How much does it cost for such research and what kind of constraint often occur with this application? Thank you.
Let me I try to find it. How
Yeah.
much?
Does it cost for such research? Maybe if we want to set up system using SIMIT, maybe he need to know about the cost.
Of course.
Yeah.
Yeah. Oh, okay. Okay. I found it from Dustry, right? Basically for SIMIT, it's quite. I think from Indonesia, SIMIT Indonesia has some special offer for continuous education. Of course, it's much better. It's a really special price, I think, for your educational. Not to worry. Then constraint wise, actually no much constraint except that how big is the simulation you want to run. Okay, for industry perspective, yeah, for those industrial user, yeah, basically the use cases will be how big is the simulations they want to use to run concurrently, how many controllers, yeah, that will be the constraint. Yeah, then they just get the license accordingly, then they just get the powerful CPU or powerful workstations to run the simulations. Yeah.
Ya,
Okay.
sedikit menambahkan Pak
Oh, yeah.
yang terkait tadi cost tadi. Jadi untuk cost sendiri, kalau memang ini purpose-nya adalah untuk university Pak, jadi kita sebenarnya based on mau didesain seperti apa SIMIT ini nantinya. Karena seperti yang tadi Denny sampaikan, di SIMIT ini sangat powerful ya, karena dilengkapi berbagai macam library, ya, energi, chemical, dan lain sebagainya. Nah, itu based on library apa yang akan kita gunakan di sini. Nah, untuk yang namanya university itu umumnya ya kita ada special price lah, itu sekitar 80% ya kalau nggak salah dari harganya untuk ke publik yang memang tujuannya komersial ya. Jadi memang university ini bukan untuk commercial purpose seperti itu. Based on detailnya berapa, kita akan lihat dulu SIMIT ini akan di-develop seperti apa. Mungkin seperti itu. Nah, yang kemarin kita juga sempat kemarin melakukan MOU ya Pak sama ITB juga, dan itu kita sedang provide untuk SIMIT yang standar yang nantinya akan diimplementasikan gitu di ITB sebagai salah satu environment partner kita gitu untuk membangun SIMIT ini di Indonesia. Kira-kira seperti itu sih.
Baik, terima kasih Pak Ibnu. Next question is coming from Pak Joni Aritonang. I would like to know about the SIMIT. What is the difference or the comparison between SIMIT and other similar product? What is the advantages of SIMIT? So we can choose SIMIT.
Yes, I see the dibandingkan aplikasi. Okay. The plus point for SIMIT, plus point of SIMIT basically SIMIT we can easily integrate with the existing user of Siemens controller. Okay, what is lacking of the today's the controller or the users? Yeah, they have the controllers, they have the program, but their machines or their plant is not ready. Yeah, SIMIT can easily couple with SIMIT controllers. Or semantic controllers. Yeah, so any user with semantic controllers, they can pick up SIMIT easily. On top of that, if you are not using semantic controllers, yeah, you can use SIMIT to couple with external, be it MATLAB or other simulator, by going through the coupling. For example, the OPC coupling. Then for the perusahaan tertentu, basically it's used for all the industry. As long as you can find semantic controller, you can couple with SIMIT. Yeah.
Kita ada di Freeport, Denny, untuk SIMIT ini. Jadi Freeport sudah
mining,
ya Freeport mining itu udah mengimplementasikan SIMIT ini, Pak, di industri.
Then use case for example, in Philippines, I know in water. In Singapore, we have water and drilling. In Singapore, we have oil and gas. Thailand, we have sugar. Basically, it's a mixture of industry, different perusahaan.
Ya, ini Pak Ibnu, ini ada pertanyaan dari Pak Dasri nih, yang paling bawah nih Pak. Jadi semua komponen material impor ya Mas Ibnu, dan ini hanya sebatas kajian laboratori, belum komersial. Mohon dijelaskan.
Ini komersial, Pak. Tadi saya menjawab ketika SIMIT ini digunakan untuk purpose-nya university ya, baik itu untuk purpose-nya university lah, research dan lain sebagainya. Itu biasanya untuk price atau cost itu berbeda dengan yang kita offer gitu untuk industri yang memang dipakai untuk productivity seperti itu. Untuk materialnya ini kan fully software ya Pak. Nanti mungkin ada dongle dan lain sebagainya. Itu memang kita ambil memang dari Jerman ya untuk dongle dan lain sebagainya. Kurang lebih seperti itu sih. Karena ini kan fully software bukan material. Kecuali ketika SIMIT ini mau di-integrated dengan real controller ya misalnya. Kita perlu yang namanya SIMIT unit tadi yang seperti dijelaskan oleh Denny. Nah itu juga kita import dari luar. Lebih seperti itu.
Baik, ini pertanyaan dari Pak Rio.
Yeah,
Question from Pak Rio. Is SIMIT limited only for process control, or can be used also for manufacturing, for production process analysis, and so on?
Okay, yeah, I see the question also. Okay, so for example, question number one, of course, for process control is a plus because you have all the libraries available. Yeah, imagine this SIMIT is open for all the industry. Yeah, for all the industry, water, cement, F&B. Then for example, for process production or soft floor analysis, it is really domain specific. Yeah, Then with this domain specific, then we need to, you can see that you may not have the library available for those analyses. Nevertheless, we can couple it. Yeah, we can couple, be it to GPROM, Unisim, Aspen Tech. Yeah, basically we can easily couple with any additional analysis software available in the market. Yeah. Then
Okay.
number two.
Number two, yeah.
Yep. Number two with the library parameter. Okay. Parameter hanya Siemens atau product line. Okay. For example, yeah, they are split into two parts. Let me show you. You can see my screen. Yep. For example, if we have still numeric drives, okay, motor or profile drive. Okay. So for example, if we have a drive, yeah, drive, then Simo code. Okay, all these basically are Siemens specific components. Yeah, Siemens specific components, dynamics, we can easily drag and drop and couple it. Yeah, you can be very straightforward. Just couple it, overlap. Okay, why we have this library? Because we are the manufacturer of this drive. That's why we know what's the addresses, what are the parameter inside. Yeah, so we can easily simulate the drive. This is up to the device simulations. Then on top of that, for the process, yeah, for the process, for example, a reactor or pump. Yep. Irregardless of the brand of the pump, yeah. For example, the brand of the pump, just pick up some of the key parameter for you to fill in from the datasheet. Okay, because all these are mechanicals devices, they have some parameter that you can get from datasheet, irregardless of the brand. Yeah. So for brand specific, then we have the library, some library for our Siemens product. But then for general process related live components, it is brand independent. Yeah. So the parameter data sheet should be the most important parameter, yeah, should be standardized throughout. Yeah. Yeah.
Oke, barusan ada yang angkat tangan tadi, Ibu Tia Arum. Silahkan kalau mau ditanyakan secara langsung.
Terima kasih Pak waktunya. So I think there are an example of the simulation about the pressure regulator. Is that stands for the pressure relief valve?
For pressure relief valve, yeah, pressure regulator, yeah. So you can see that this is just a sample calculation, and you can see that it is just a multiplier with the gas with some set point. At the same time, that if you know the calculation about the pressure relief valve, yeah, I think that's more that was easier. You just set the set point with the value exceeding the set point. Yeah, you will open up the valve. Yeah, it is possible to simulate it. Yeah.
Does SIMIT code simulate the dynamic relief load during overpressure or?
Yeah, for the chemical basic library or FlowNet library, yeah, it is simulating the dynamics simulations. Yes, but it is up to the limit of the water steam liquid, just the normal liquid without chemical reactions. But the thermodynamics, the the balance, yeah, the balance equation is still there. Yeah, not until the chemical reactions part. Yeah.
Okay, thank you.
Then on top of that, let me show you the website. Yeah, so basically this is the same website. This is the website in SIMIT. Yeah. it is a continuous improvement software suite. You can see that there are so many additional library available. SIMIT, Simotions, RFID, machine simulator, some auxiliary library, model generator. Yeah, this is more related to discrete industry. Yeah, factory automations. Yeah, Simotions. Let me TwinCAD. Yeah, TwinCAD is another standard in the market. Yeah. So you can see that SIMIT coupled with TwinCAD. Yeah, it is also possible. Yeah, basically, you see, back off another brand of PLC. We can couple it with SIMIT model generator. Okay. The plus point for us, basically, we have so many documentation, application examples that you can make reference out of it. Then at the same time, you can come up with some solutions which is related to your industry or to your expertise. Yeah, this is for process example. This is for discrete. Yeah, more and more come in the future. Yeah. Yeah, this is example for, yeah, let us take a look. I'm also interested. SIMIT with NXMCD machines. Okay, auto sizing with machines. Yeah, cylinder positionings. Then this is for the winding. Winder and tensions basically is for the textile industry. The 3D model. Then the servo. Yeah, machining center. Yeah. So basically, it is very, wow. You see, got so many examples available. Yeah, basically, it's very powerful. It takes time to explore. Yeah, TwinCAD with Berkov, SIMIT Ethernet IP with Rockwell PLC, if with Unity, HMI. Yeah, basically, there are so many coming into the picture. Very comprehensive, very interesting. Then let me see.
Okay. Next question from Pak Joni Aritonang.
Trim.
I would like to know about the utilization of SIMIT in nuclear power plant.
Oh, no, nuclear is not the up to our capability. Yeah.
Oh, okay.
Yeah.
And from Barrio, SIMIT manufacturing execution system, MES, or digital twins?
Yeah, it is
The
digital
twin, is that any tool for forecasting?
Okay. Okay. Interestingly, digital twin is a very big topic. Yeah, digital twin is a buzzword. Yeah. For Siemens perspective, yeah, we have quite a few digital twin solutions. One of them will be COMOS, basically for the data digital twins of the plant where you keep all the data. For SIMIT, it is a digital twins in terms of behavior of the machines and or the plant. And then we also have the GPROM. GPROM is also for high fidelity plant in terms of digital twin, but there is no tools for forecasting. Yeah. Forecasting or predictive maintain predictions will be another software suite. Basically, there's a few software suite for these predictions. Yeah, we can find more information if you are interested with regards to that. Then can we do customize for the template? Related to the datasheet, can we do customize for template? Related to the okay. For SIMIT, yeah. So basically, with these components, yeah, if you found out that okay, the parameter is not enough. Okay, okay. So if you found out that this one is not enough, yeah, basically yes, you can modify the component, and then you add in with the CTE. Then subsequently, of course, you must tie the additional parameter into the calculations. Yeah. Yes, it is possible.
Oke. Ada pertanyaan lagi? Silakan kalau ada ini. regarding your presentation material, is it also possible to?
Yes, yes, we can send over. No worry.
Okay, okay.
Yep.
Masih ada pertanyaan lagi kah? Okay, still one question more from Pak Ferry. Yeah.
Oh, okay. Yes. There are two things. Some of the things you can't replace by manpower. Yeah, because sometimes software is a software. It's not like by running certain software. Okay, automation. Yeah, really depends. Okay, really depends. Yes, the software is not cheap for Indonesian company, but there are few things. Of course, we can get discount. Yeah, can get discount from IBNU. Yeah, there's use case, specific use cases. You can just get some reason. But again, this is based on my experience previously. In one of the there are some, for example, for maintenance. Okay, there are some software suite which really can reduce the job of the maintenance guy. Of course, subsequently they may trigger some reduction of manpower, but of course, it is the safety of the personnel. It is also taking into the considerations. The software wise, let us think it this way. On top of, imagine you have the benefit of labor cost in Indonesia. Yes, you have the plus point. Imagine that you can use this software, then you develop and then you deliver it to the world. Yeah. So instead of using, okay, and also you can use it to deliver. This is also sometimes the plus point. We have the Indonesia basically has the benefit of having a huge populations. Yeah, the think tank basically is very big in Indonesia. Then we come up with this, you can easily become a hub of delivering solutions. But of course, no worry, the discount or the pricing can be discussed with IBNU. Yeah, that's the that's the Southeast Asia. Basically, sincerely, Southeast Asia, all the country except Singapore, the cost is low. Yeah, but yes, there are some strategy, some discount applicable to the user in some other country. Yeah, and then just a business perspective. For example, if you are buying or if you are selling iPhone in Indonesia and selling iPhone in Singapore, yeah, eventually there will be a very minor difference, because otherwise people will buy from Indonesia and sell to Singapore, or buy from Singapore and sell in Indonesia, because nowadays the world is so small. The geography basically can't really limit the transfer of the products already. No worry.
Oke, ada pertanyaan lagi? Kalau nggak ada pertanyaan lagi, kita akhiri webinar sore hari ini. Again, on behalf of Badan Kejuruan Teknik PII, we would like to thank you very much, Denny, for your
Terima kasih.
presentation and also your answer for some question from the participants. Terima kasih Pak Ibnu Koldun yang juga sudah memberikan presentasi tentang SIMIT pada sore hari ini. Terima kasih pada ibu-ibu dan bapak-bapak sekalian yang sudah bergabung di acara webinar BK Teknik Fisika sore hari ini. Kita ketemu lagi minggu depan ya, Selasa, Rabu sore. Terima kasih. Mohon maaf kalau ada banyak hal yang kurang berkenan. Salam sehat-sehat selalu dimanapun berada. Terima kasih.
Terima
Thank you.
kasih Pak Edi,
Terima
terima
kasih.
kasih teman-teman semuanya. Mohon izin pamit.
Terima kasih.